Testing. Testing 1 2. Testing 1 2. Well, I should have audio now, but I have absolutely no idea what went wrong. I just had to manually connect this. Why on earth? How can a reboot cause that? I think they renamed it. Maybe it's the thing is named differently or something like that. According to this, I would have an automatic connect from OBS mic to two things. To system. What? To system? No, that's a different one. Where is this connected with? This OBS input. And the other one? Yeah, OBS monitor. So it is connected to OBS monitor. And it was not connected to OBS input, or this is just called differently. I think I upgraded OBS. No, it's called differently. Therefore, OBS was not connected. No, I'll have to look at it later. And I don't have music anymore because now this one is doing something else. Let me create a new console. Hope that this is good. Okay, is there anyone here? I should have no music, but I should have voice now. Yeah, that doesn't look like much, but there is a lot of structure in it, and we're going to find out what by yeah, I managed to get back Post Bunny. That was just stupid. I mean, it wasn't stupid. I upgraded. I think my microphone is completely in red, so I'm gonna turn it down a bit. Testing 1 2. Hopefully this is good, or maybe I should set it minus 3 dB, 0 dB. I don't know, what did I have then? Testing, what do? Oh, this is good. I have no idea what's going on here. One moment it's in red and now it's good. Hello, Hugh. Okay. I need to plot dots and not lines. This is plotting lines. I have no idea how to use this thing. So I'm just going to ask, going to have to ask it again. So that used to look like absolute nonsense, but now you see that everything is at a certain height. No, that's nonsense, actually. I need a lot more points. What? Yeah, I guess the vertical axis is just an integer, and we have values 0, 1, 2, 3, 4, etc. Not surprising, but that can't be right. Let's test this function first, because I just made it up before we do any plotting. Better make sure that the function is working. Don't need any of that. I just want to know the result of. Say auto result is factorize and count. Well, you know the drill. 5 7 of that. And that I want to print that. Probably doesn't work, but okay. How can I print tuples? Within no time I'll using my debugging stuff again. Yeah, what was I doing? Include IO stream. Don't you hate that? Okay, so standard get 0, yes, comma, standard get 1, res, comma, standard get 2, res. Get it out. No. Totally, absolutely 0, no. Let me turn on the lights and I'll be back. That is such a failure. Such a failure. Okay, I come back and I don't have music anymore. Oh, there it is. What's going wrong here? I cannot believe that's the problem, but well, that is not a problem. Okay. $77. upper limit is big. And then I think we need 4 iterations. So this is not a perfect square, thank you. 78 is also not a perfect square. It thinks it is a perfect square. What the hell? 78 n 78 times 78 minus n 307. Since when is 307 a square? So my perfect square function is wrong. What? Okay, do that again. Twilight Zone things. No, went from the beginning. Yes, next step. Q77 gives me a D of 152. That's not a perfect square. Increment it. This gives me a D of 307. That is not a perfect square. Step. Calculate the square root of n. N is 307. Auto. Auto. Yeah, okay. Number. I'll even give it a round here again. Just in case. That is impossible. Come on, you can calculate the square root of a double or whatever. This conversion must be exact, I'm sure of it. I don't need it here either. Because we already checked that STD square root works. Maybe what I should do is just return the root so I don't have to calculate the square root twice. So that now it's not working for n equals 0 because that is a perfect square. Well, I'll figure it out. No, wait. Do I not need it? NQ squared. Yeah, maybe I need it. I just can't have its edge cases that don't work. Otherwise. Damn it. That's better. Okay, so third time, also not a square. Is that a square? Nope. This is a square. Yep. And that works. Now you get the right values back. 109 and 53. In case anyone doesn't believe me. So after 4 iterations, we found that factorization of 5777. Oops, quit. And with that fixed, go back to on this. I want to plot the number of iterations for every value up till, let's start with 10,000. Let's do every value, well, let's do every odd value starting with 3. That's more like it. So horizontally you see the some integer, right? And then using my algorithm, I'm factorizing it. And vertically you see how many steps that took. So it takes like exactly this many steps to get to the solution for, well, some of the numbers. Never ever, there is not a single integer for which we use this kind of step. So, wow, why? No, because these things look very much like a straight line. It's logical, I guess, to not print this straight line, but print the slope. So instead of printing this y value, we print the y value divided by the horizontal value, which is n. Going to print that. And that's a floating point, so I have to make it a double first. And now it is revealed that they are not straight lines. For lower values, the slope is horizontal. So really, it's not a straight line, it's something that starts horizontally and then starts running like a line. Moreover, this is here slightly less than a half, right? I want to print a red line here. I'll have to ask ChatGPT. Maybe we should look up the documentation. Let's only bother ChatGPT with it. Excuse me. Void. To horizontal line at double Y or something like that. Yeah, maybe. Is that a double? Might as well make doubles. Nah, I don't want to make doubles. I work with integers. Yep, so this is a line 0.5 and we're not there. So is it below a half? You know, what's going on? Well, for that we go to 1 million. And then we have a lot of points, so maybe it should go 10 times as fast or something like that. That takes a long time. Okay, so that kind of indicates, I guess, that we just approach a half here, right? Slowly. And what about this one? Well, that is 1/6. I can draw a horizontal line. For that, let me even make steps 10 times as large. And I want to draw a line at Y. So half divided by 3, that's 1/6. Yes, so it's either a half divided by 1 or a half divided by 6, by 3 I mean, or maybe I should draw several of those lines. Or int divisor, the d of divisor. D is less than, well, let's not make it too idiotic. 12. D, so all the odd numbers. D of divisor, we divide it by 1, 3, 5, 7, 9 and 11. That's already a lot. No, you could doubt if that's true, because it's already a million and I can visually see that it is pretty much below it. As well as it is here, a whole pixel. I don't know. Anyway, I'm going to increase the resolution again in the beginning here. Oops. So let's start with v equals 3 indeed, and then increment v with at least 1, but otherwise just multiply it with a small value. Should give me more. Might take a long time. No, that's fast. So now we have a lot of dots here, and then here they spread out a little bit, but that's not a problem, because now we are going to take the logarithm horizontally, make the x-axis logarithmic. How shall we do that? That means that my n values must be logarithmic values. No, of course not. I want to plot them logarithmically. Plot x. Push back something, and then here we draw plot x. Okay, what I want to push back here is the logarithm of n. That should always work, I think, because n is just 3 or larger. Oh, looks like my x is 0, but on the other hand, it's just way smaller. So that I shouldn't go to 1 million. I should go to 6. Yeah, x max is 6, but that's only because that's a logarithm, right? So can we do maybe a number const n max? Because it's probably not 6, now I think about it. I think it's a natural logarithm. So this is more correct. Wait. It's not correct. This must be nmax. Uh-oh. Now we get to see the scattering. There is scattering. So there is a certain uncertainty. Maybe not. Maybe not. You see here, this thing here? It's a slope still. And then at some point it drops down. And then we get another line. And it drops down, another line. There is still more structure in it. Maybe that structure will be visible if we put points even closer to each other. Yeah, and these red lines, yeah, they're still the asymptotes. Well, no, there's one missing for this. What's going on here? Why is there no red line here? Or rather, why is there suddenly a blue dots here that I had not seen before? Here, also another one in the middle, and here as well. Are you telling me now suddenly I have points that have to be divided by 2? Looks like a quarter. We totally missed those before. I'm shocked. How is that possible? Yeah. There's more of them. Okay, let's draw even denser. I want to see the structure in the plot. It is hard to see. Here's also something really strange going on. Really strange. What the hell's going on here? You see here, there's an enormous gap here. And another gap, and another gap, and a huge gap here. There's a gap here. There's a huge gap here. There's a huge gap here. Wow, so big. And here one, and here. And all of these. There's like nothing here. And here also. Oh, that is so, well, actually awesome. What is going on? Why is there, for this value here, or for these values rather, can I zoom in, like maybe just draw between 8 and 10? This is around 9, right? It starts at 9, it seems. Now horizontally you have the natural logarithm, I think. To e to the power 9 doesn't ring a bell at all. Let's remove the red lines. They're kind of clear now already. Could it be just an artifact? Let me draw even more dense. I don't care how long it's gonna take. I think if I reduce this with a factor of 10, do we still see it? Yep. Could probably even remove another factor of 10. Do you see that gap? Okay, this gap here just starts at 9 indeed. So you still see it. Plus the huge gap here as well. The gaps here. There's loads of gaps. Loads of gaps. Okay. So I'm going to can just make them even denser. And now where is the gap? That's an artifact. I think it was an artifact. Yeah, well, too bad. That would have been special. Now what happens if you just do every integer? Oops. I'm going to go back to every integer. They must be odd though. Oh, I'm not testing if they are odd. Oh, I'm an idiot. Yeah, I forgot to switch back to the 2 times v plus 1 times thingy. Yeah, we have to do only odd stuff. Let's see if the artifact is still there. We do it like this. Yeah. Wait. No, I think that's what I want. Definitely an artifact. You see, there's enormous gaps here. Why the hell? Unbelievable. But it's all gone like this. It's not a real gap. It's not a real gap. It's just still, yeah. So let's say if you want to factorize this number, then the only thing you have to do is search in this region. There's an upper and a lower limit here for this one. Search in this region, and then search in this region, and then search in that region, and so on. Sorry, Emra, he's probably already gone. What kind of curve is this? Is there a way to blow this up, maybe? Maybe double logarithmic? Might be interesting. Let's plot the standard log. So you know it's x and y is logarithmic. I have no idea what I'm looking at. This looks like a straight line, but yeah, but what about this line then? We have lines here, and then suddenly it's... Nah. I think these are the real lines, and this is just tuk 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 tuk. And then this kind of artifacts here. Looks all very strange. Very, very strange. And you should add some noise to it. Multiply with a random factor instead of a fixed factor. It's definitely a nice picture though. I like it. It is a nice picture. But I have no clue what I'm looking at. No, that was very beautiful, but I don't think the double logarithmic thing is helping me at all. Let's remove that again. That was the logarithm of the slope of the number of iterations required to factorize integer n with my algorithm. Just so you know it. Okay, what shall we do? I think I need to, I want to see some hard numbers, you know, when exactly is the slope well, that value. No, it's 1 million points take a long time. Okay, now I'm not sure what I'm looking at here. What the hell is this? What was that? Why did it suddenly look like that? I thought we were talking about horizontal lines. More or less. Definitely not going steeper and steeper. What? Okay, someone help me. Before we had something that went up. Oh, this is just way too high. Oh, I forgot to divide by n, I think. Yeah, that's the reason. Why should be this divided by n? That's, I've got that one. I removed that one. Okay. So now we have again the slope. Well, if you can call it a slope. It's not really, it's nothing to do with the derivative, but so what this half says is that for if we increase the number that we want to factorize with 2, then we need one more iteration step for this one. And I want to know for which integers that is, because if you give a random integer, you can go, well, there, or there. So which one end up here? Let's say we just cut off at 0.2. So everything above 0.2 is definitely belongs to this line. And then just print the result. Why is that printing 0 all the time? Oh. Yeah. I'm being stupid. Sorry. Yeah. It's printing 0 because that's what it is. That's the reason. Which means that we can calculate the exact number of iterations, namely n plus 1 divided by 2. And maybe that plus 1 is the reason why it is curving like that. Yeah, because, well, no, not exactly. This m here is also involved. We started the square root of n, and then we go to n plus 1 minus 2. So the total number of iterations in that case is, yeah, n plus 2, n plus 1 divided by 2 minus the square root of n-ish, which introduces a really small noise, or plus or minus 1, because of this round off here. What does this mean? I think it means that n is a prime, if we get here. We get here, we could not factorize it. If that's true, then I should return n comma 1. But I suppose I should check if indeed the result is a prime. All these n's, that they are prime. Write to a file. I'm convinced. Yeah, those are primes. 13, where we start with 13 instead of 3, I have no idea, but 13, 17, 19, 23, 29, 31, and so on. Okay, but now I don't recognize prime numbers anymore, but these are all primes. So that is the reason. We can do a few checks. Let's say, is this random check? Is that a prime? And if so, what is the next prime? Well, that's not reasonable, because we're multiplying it by 0 point something, 0.001, or what was it? And then the next prime. Or no, not even that. We hit by coincidence a prime, but at the very least you can check if this is a prime. Yeah, I have a better site for that. Factorize. Yeah, the green yes says it is a prime. And then that one, also a prime, that one, also a prime, last one. Yep, they're all primes. Good. So yeah, well, that's not super interesting, so maybe I should not plot those even, because they're primes. If y equals 1, so just skip all of those. Oh, that's bullshit. What am I doing? 2dd below there. Don't do that. So like that. Try to factorize n. And if the smallest factor equals 1, then don't push it. Otherwise you push it. So, okay, so the next thing then is we want to check if y equals is larger than something else, a tenth. Now we want to zoom in on this, so that is larger than 0.1. That should be pretty good to get the top one. Okay, that's pretty clear. That's 3 times a prime. Do we have an equals and then anything but the 3, but not followed by. So how do we do that? I don't want to find the first n, the first equals. I guess you should do anything but an n, followed by a space, followed by an equal sign, followed by anything but a 3. No, so there's always 3. Yeah, then this must be a prime, otherwise it would have found a better factor. It tries to find the factors that are closest together. So these must be prime as well then. Check one. That's all prime, 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 prime. Look up. Yes, prime. Okay, all of them are prime. Also in the beginning. Looks like primes. Yeah. Okay. Starting to make sense of this output. No, but the next one is then 5, and then the next one is 7, and then the next one is, I think, 9. I want to see the 9 as well. So let's do if the smallest factor is 3, then I don't want to see it. And in order to get all of these, we want to look at, I guess, 0.08 or something like that. Larger than. Yeah, that's clearly 5. I want to keep the 1 separate. It's a very special case. Prime. What? Yeah, well, I don't know. 0.055. What do you think? And that is then the 7. So we filter out the 7. And then want to look at these, which is larger than, I don't know, 0.045 maybe? I think so. Yeah, 9 is there as well. So it's just all the odd numbers. Now let's see if we can understand that. So if y is the next number, complicated. It's not very trivial. It's not very trivial. So what you roughly saw is that Q needs to be more or less n divided by 2. To be precise, n plus 1 divided by 2 minus the ceiling of the square root of n. But the square root of n can be ignored. No, what's the word? Yeah, no. Well, it's much smaller than n. The plus 1 is, of course, even less. So it's about n divided by 2. Before we are done with this loop and then exit like that. It just has to increment q for upper limit q number of times minus the starting point. But it's still more or less that. And then we say, if we find that, sorry. Now let's do it exactly. Okay, so if n is prime, then we don't find a factorization, and we'll leave the loop after ... iterations, where ... equals. Well, we begin with m. If the upper limit was m plus 1, then we do the following. Q is less than m plus 1, yes, because Q is m. So then we do plus iterations, which is plus 1, and then Q equals m plus 1, and it's no longer true. So the number of iterations is upper limit minus m. Okay, let's see. That is the exact value. Let's call the number of iterations something. Number of iterations I. 2i is n minus 2 times the square root ceiling of the square root of that. So left and right multiply by 2. Get 2i and then n plus 1 and then that. I didn't do the plus 1 yet, so plus 1. And n can be written as the square root of n squared. So this is more or less just too bad of the ceiling though. The square root of n plus 1 squared. So I is more or less the yeah, I can't make anything else of it. It's n divided by 2. But for small n, it's different. But then I don't know, nothing to do here. I think. Maybe you know, not exact, but also not n divided by 2. Is there another reasonable? I think there's a pretty reasonable approximation that is better. It just ignores the ceiling roundel. Then why would I do that? The ceiling is up. Ceiling does a round off up to 1, 0 to 1 times 2, so that's already larger than the plus 1. Might as well ignore that. So it's just n divided by 2 then. Okay, now the big insight is that if n is 3 times some prime p, then why oh why do we get an I that is more or less equal to n divided by 6? Who can explain that? So by the time that q is 1/3 of the upper limit, I get a perfect square because n is divisible by 3. What? Why? Why is that logical? How is that logical in any way? Well, of course it is logical. So totally logical because, well, yeah, I just have to write down the formula and then we'll see. Less talking, more typing. Here's the square root of q squared, which is this, which is d plus n. D plus n, where d is the square of k. And that should be more or less equal to n divided by 6, I guess. I mean, this is just an n squared again. So this can be ignored, and then we can take the square roots. And then we get just what is in here, and then we can ignore that. So that is just more or less n divided by 6. So the larger the smallest factor becomes, the less we are equal to this. And we're also ignoring the square root of n compared to n. So if n goes to infinity, then the square root of n is absolutely nothing compared to n. So then we are very, 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 very close to these values. But even if n goes to infinity, by the time that the factor approaches the square root of n, okay, in general, like obviously, I would say. So if n is some factor times p, where p is prime, and thus, nah, not thus, well, it's just f is odd, obviously. N must be odd, so f is odd, p is odd. P is prime, and f is much smaller than p. Well, then q, which is more or less equal to the number of iterations, because it's more or less because we also have to subtract the square root of n. So q is then, yeah, more or less n divided by 2 times f. However, if f is of the order of p, let's write it down. If f approaches the square root now m is the ceiling of the square root, so that's pretty damn close to the square root. And it approaches it, so I want to make it smaller. Let's say L, where L is then, yeah, not that big anymore. This is not the L that I used before. I mean, before I used plus L. But then we're talking about the FSP. The larger factor. Now, in this case, f is the smaller factor, so I have to subtract L. Actually, due to K. This is not including K. There's a completely different L than I used before. Maybe I should use something else. What do I have left? How about V, K, L, M, N, O, P, Q? R. Oh, R. Okay, in that case, what does Q has to be so that we have our factorization? I think I have to start with K again. K is so N divided by F minus F, where N divided by F is P, so it's just P minus F, but let's work with N rather than new P, divided by 2, which now we can write as N divided by M minus R minus M minus R divided by 2. Yeah, that's starting to, it's going to 0 theoretically. Can I say something logical about that in terms of R? Probably should multiply this with M minus R. So K times M minus R, M minus R equals N minus M minus R squared divided by 2. Now let's leave the 2 as well on this side. K M minus R is N minus M minus R squared. So I multiplied both sides with 2 and with M minus R. 2. Yeah, we can work that out, I guess, as being n minus m squared minus 2mr, but that becomes plus then, and then minus r squared. Let's divide by m on both sides. divide by m, so then this becomes 1 and this becomes r divided by m equals n divided by m minus m plus 2r minus r squared divided by m. Now yeah, this is more or less m, right? I mean, n is like huge and yeah, no, is it? Let me build it up. M is the ceiling of the square root of n. And that could deviate how much? Yeah, whatever. That is more or less m. So this is just m minus m, drop out, r times 2 minus r divided by m. Which is more or less equal to... Now I'm going to use that r is just way smaller, let's say much smaller than m, so it is more or less 2r, yes? Plus we have here more or less the same thing anyway. So let's remove this factor and replace this with 2. And then you get k, 2k equals 2r. K is more or less r. I think this step is not contributing anything. Yeah. And then we have to calculate Q. So from that follows that Q is Q is still the square root of k squared. Okay, this is k squared, so we get k squared plus n. And r was already less, which is more or less m, right? So r was already small compared to m, so it is r squared is nothing compared to n. Okay, I'll put that step in between here in case I ever want to read it again. Square root of n, which is more or less n. Which, yeah, more or less, because we don't have a ceiling here. That cannot be right. That cannot be right. Damn it. What did I do wrong here? Q must go to 0, obviously. I rather had expected maybe R or something like that. Oh, that's exactly what is happening. Yeah, it is correct. Q is more or less m, from which follows that the number of needed iterations Yeah, I have to. Q starts at M, so I need an approximation in terms of R here anyway. This R then, right? How do we do that? Okay, this is exact. Q equals the square root of k squared plus n. I'm gonna put n first, because it's larger. And then we want to say that is more or less equal to the square root of I need to express this as m plus r, I guess. So is that possible? Doesn't seem reasonable. Yeah, Boys Bunny, yeah, well, maybe. I mean, 1.5 hours ago, I usually stopped streaming, but then I'm not going to bed, so. Yeah, what I really should calculate is the number of iterations, right? So iterations is Q minus M. So that's more or less square root of M squared, whatever, plus K squared. That was more or less R minus M. I mean, R is small compared to M, but M is still huge. Yeah, N is huge, like 10 to the power 80. M is like 10 to the power 40. So even if R is 10 to the power 10, then it's still much smaller than M. So we have here 10 to the power 80 plus 10 to the power 20. It's completely, it seems that we can ignore it, but then we subtract M. If you would ignore it completely, well, then you would get just m minus m 0. That's not what I want. I want to find out now what this is in terms of r. Yeah, I just have to treat this. Looks like a square, but I have to treat it like 2m times something. That's the trick. And this is the square root of m squared plus 2 times m times r squared divided by 2m. Plus r to the power 4 divided by 4m squared. So absolutely nothing. How do you do that? R squared divided by 2m squared, because it's nothing anyway. I mean, the ballpark figure was this is now 10 to the power 20. This is 2 times 10 to the power 40. So it's 10 to the power minus 60. I'm allowed to add that. Minus m is the square root of m plus that squared minus m is something is missing here. Where's my m squared? Totally had an m squared here. No, wait a minute. I'm not. I squared it like that. So this is m squared plus 2 times that times m. Yeah, okay. This is what I wanted. So we take the square root of that, and then we subtract m, and then we end up with this. Which is nothing to do anymore with n divided by. So we would, if f is around the square root of n, and we would follow this formula, you would get like the square root of n divided by 2. Well, this is way, 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 way smaller than that. In fact, if r is much smaller than m, this is already approaching 1 by the time that r is the square root of m. So the number of iterations goes rapidly down when the two factors approach each other. But yeah, well, the only reason is that we started with an offset of m, because we started m. If we would just start with q at 0, which would be ridiculous because there's never going to be a solution until we reach m, then in the end we would be requiring m steps. So then I don't know, now I'm seeing the factor of 2 here, but if we don't do this, then I think the curvatures disappear more or less. But then it also becomes incredibly much slower by the time the two factors are actually equal-ish, which is a shame. I wonder if it's possible though to speed it up a little bit. No, that doesn't make any sense, but I mean, just keep adding one while you know that you need. I mean, in the end, you know, keep it. Adding one is ridiculous at some point. You just really have to take larger and larger steps, I think. If we can find out what the bandwidth is, everything falls in. Bandwidth being the spread here. So suppose this is basically Q vertically here. So we're counting up Q, add, and we just don't find the blue dot. It's exactly squeeze in between here, and then by the time we're here, we should know that we did pass the line. We're not going to find it here, and then it doesn't make any sense to just keep slowly incrementing Q. We should just jump to there, and then find that the n was a prime, in this case. Or, no, I removed that in this one. Did I remove that in this one? 005, yeah. So that is divisible by 3, in this case, I think. I'm interested to see this graph, I have to say. Zooming in on the lowest part. So let's draw it till, well, maybe not draw it until we have 0.01 or something like that. 1/10 of this. See how that looks like. It's so weird. Why do we have a 0 here? I think if we immediately find it, is the number of iterations then 0? I don't think so. Though the very first hit is correct. Is that 0? That's how it's treating it. So it immediately returns it. Then we have 0. Nah, I think I should start at 1. And the number of iterations is more or less the number of times we have to calculate the perfect square. Determine perfect square, calculate the square. It's better, I think. Makes more sense. But yeah, because the number of iterations is divided by n, and this is the logarithmic scale, is it still? No, I don't think I want. Yeah, the natural log. Let's do the 10 log, so we can at least recognize it a bit. I think that's just 10 log, right? Much better, but now it's going way beyond 6. Why? I thought I stopped at 1 million. This is a million, so why do we go to 10 million? Or what is it? That's not 10 million. Maybe it is 10 million. So it's still going near 0. Can I draw a horizontal line at 0? Not even get to see my x-axis. Yeah, yeah. Now it looks like there's a line here, but is it? If you zoom out, it's like lines that run like this, and now it looks like they run like that. What is this step from here to there? So here are the graphs like this. These are on the line. These are on the line. All these things are on one line, with a little bit of scatter. And these have hardly any scatter. Why is that? I think it's just constant. Yeah, it's a constant number of iterations divided by n. So totally not interesting. Let's not divide by n and then see what we get. Yeah, not divide by n. So now we really plot vertically the number of iterations, aka Q, the Q that we find. Nothing to be seen. Oh, yeah. Okay, the reason that we go beyond the 6 is that I let V run up till n max, and then we multiply it by 2. So we go up till 2 million with the values. Maybe I should just do V max divided by 2 here. So yeah, and the number of iterations are like huge for certain factors. But now we know this is when 3 is a factor, 5 is a factor, 7, 9, 11, 13, 15. So if the factor is pretty large, and of course it should be large, otherwise factorization would have been super easy. And you sit somewhere here, it's not that bad. Let's zoom in at less than 100. No, less than 1000 iterations. What I want is to see randomness. This looks like random, but is this really like noise? Noise is random, or is it still an artifact? I'm afraid I'll just have to calculate it for every value, which is pretty slow. That's very slow. Very, very slow. Yeah, Gordon bombing. We can maybe not a million then. Let's go to 100,000. And then let's just do again everything. I don't know how slow this is going to be. Very slow. Very fast. You see, there's nothing random there now. It's not random at all. I think we can do 1,000. Now I'm using optimization. That was so much faster. I'm listening to my song, my stream song. Oh, you're not still. No music, right? What's going wrong? Why do I have no music? Oh, there's the output. Still such weird artifacts. What the hell is this doing here? Right there. Doesn't make any sense whatsoever. What the hell is this, man? Why? That's a weird curve. I think it's a weird curve. It's not a parabola, how do they say that? What is this for curve? What is it? Is it exponential or something? It's not exponential, I think. No, it's approaching a straight line here, I think. This is really weird. This white stuff here, because now I'm calculating it for every integer. So there is no way that there is an artifact here. There must be really a gap here. There's just not a blue dot here. And I can understand that there is no blue dot here, but why would there be no blue dot there, nor there, nor there, nor there? Why? They look so much alike. The pattern. Every time you go to the next curve, it looks the same. See, you have two single dots here. Also there, also there, also there, and so on, 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 and so on. I really wish I could zoom in. How accurate is this? Can I not zoom in? I want to zoom in this square here, or this square. 4.525, and then 400 to 500. You guys don't hear music, right? Let me fix that. This is good music. The idea is that you hear music when I turn this on. I think that's the trick. Much better. Let me double check. This is royalty free. Yeah. Okay. And 4.5 is less than x, and x is less than 5. Yeah, now it's really bad time. It's past midnight. Jill, gonna quit here. Oh, that didn't help. The bloody red line is screwing with me. Okay, cannot go to bed. I have to remove the line. Well, let's double check. So I'm really generating every odd number. I would even do that because I'm zooming in a certain part. I probably should calculate backwards what the values should be then. You know, x is the 10 log of something, and then that must be between 4.5 and 5. 4.5 and 5. Well, please look the other way. No, bullshit. I'm having an n, number n is that. Then we can do an x, and then we can store n here if and only if that is the case. And I'm still doing way too much, but at least not that much. A little bit less. I think. I hope. Yeah, definitely. Must be faster this. Seems about this, like, I mean, this is it. There is no artifact here. Every integer is accounted for. And then you have clearly a gap here. Not only do you have a gap here, but here as well, and there, and there, and there. Intriguing. Well, there is also a little bit of noise here. Let's see, I think that these two are the same as these two, are the same as these two, are the same as these two. That, what? Is some noise. There is some noise. That noise could be very well the round of the ceiling of the square root. And here's suddenly one extra inside the gap. Or suddenly, not suddenly, oh almost suddenly. This one skips 1, then we skip 2, then we skip 2, then we skip 0. Noisy. There is some noise, but there is still more structure than the noise here. Wouldn't it be nice if you could hover with your mouse on a dot and then see what n is and what the factors are? Now you could really do something. I'm going to go to bed.